So the first thing in the agenda is going to be the demo of Kubernetes and Jenkins. And Vic, are you on the line?
Yes, can you hear me?
I can hear you and I can see your screen. Thank you for sharing. And
Killer.
so with that, the floor is yours.
All right, so I'll just get started. My name's Vic. I'm a cloud solutions architect out of Santa Barbara. I work for Google, and my Twitter handle is @VicNasty. So today we'll walk through kind of how you deploy Jenkins to Kubernetes. I know we did a little bit last week with Lachlan, and then I'll go through a brief glance at the Jenkins pipelines, and then how we do CD and canary deployments with Kubernetes to Jenkins. So to deploy Jenkins, you have a master pod generally in a Jenkins deployment, and that one has a persistent disk attached to it. That's where all of the Jenkins configuration for the jobs and how Kubernetes is set up can be hosted. So here's an example deployment manifest for that. This is very similar to what's in the charts repo today. So you guys can go install that with one command using Helm. And in this case, I've been using the HTTP load balancer, and there's other cases where I've used proxies and queue control proxy and port forwarding to get to the Jenkins instance where I didn't want it to be public facing. So in order to get the HTTP load balancer in the Google Cloud to give you access to Jenkins, you can create an ingress resource and then point it at the service name, which here we're pointing just to the UI.
Just a moment. Can whoever's not speaking just put themselves on mute? We're getting a fair amount of background noise.
I can deal with a baby. The way Jenkins works is basically you have a master node, and then it talks to some agent nodes that then can execute build processes for you. So in the Kubernetes context, the way that those get launched is by using the Kubernetes plugin. And what this does is basically map a pod definition to a Jenkins label. And within your Jenkins jobs, you can say that a particular job must be run on a pod with a certain label. So you can map those things together. Each build kicks off its own pod, so you get a clean, fresh, clean room environment for your build, which is really nice. And you don't have to worry about shared workspaces or anything like that. You can have a shared host path if you do want to share a workspace to cache artifacts or things like that. And you can also, bring your own Docker image that has all of your dependencies already baked into it. And in this case, it's using a service account within the Kubernetes cluster to launch its pods. Here's the UI for that. It's pretty simple. You can map host path volumes. There's actually more advanced options now with being able to set resource limits and those kinds of things. So there's quite a bit of flexibility in how you get those pods launched for your builds. The Kubernetes plugin was created by Carlos Sanchez. He's been doing great work there and making the Kubernetes plugin better and better every time I look back and upgrade that plugin. So I wanted to thank him. He's pretty awesome. And the way that we orchestrate the deployment of an application in Jenkins is through Jenkins Pipelines feature. And this allows you to define your build, test, and deployment pipeline in a single file that then you can audit. If you have a code review process and someone tries to change it, you can do code review on your CI/CD process. And if you have various environments, you can reproduce that same exact pipeline on different Jenkins masters, for example, if you want to test things in your CI/CD pipeline. And I've found it to be quite flexible in what it allows you to do. It's written in a Groovy syntax, which for me took a little bit of getting used to. But once I kind of saw a few examples of how the Groovy syntax worked, I was able to get going pretty easily. So here's an example. Here's a Jenkins pipeline that's going to run within any node label. So I could add a label here to tell it which particular pod template I want to use. Here I'm going to use anyone, which is probably not a best practice, but then I can define variables for my build and then use them within various commands within the pipeline. So the way my pipeline works here is I'm going to check out my code, then I'm going to build an image from that code and then run tests within that image, then push that image to a registry, and then deploy my application using kube control apply. So there's nothing really fancy here like Helm. This gives you the flexibility to use whatever existing practices you have. You could use kube control directly or any of the other tools around Kubernetes. Once you've completed your pipeline definition, it'll run your builds for you, obviously, and give you this nice output that lets you know how long each stage took and whether it passed or failed. You can also click into an individual stage and see what the logs are for that stage, which is pretty useful. So I know that might be a repetition from last week, but let's talk about the continuous deployment aspect of the CI/CD process. So can you guys still see my screen?
I can.
Cool. So the way I think about this is that I want the developers to have as close to an environment as possible to what they're going to be deploying to. So what I was using is you can have separate Jenkins or separate Kubernetes clusters, but basically have them in the same environment. So if you're running on bare metal, have your developers deploying to your bare metal deployment with the same networking, with the same everything that you can in their clusters. So basically, developers can push code. Jenkins will build it and build them a development environment within that cluster. And then they can iterate on that branch as much as they need to until they're ready to commit to one of the branches that pushes their images and their code to the production environment. Once they have code that they feel is ready for that, you can do a code review to get things into a staging environment. Once it's in staging, maybe you have some monitoring in place that allows you to decide whether that was actually a beneficial change or not, and you can maybe roll it back or push it back out to the rest of production. So the way that this is working in the production environment is I have a scaled down version of my application in a staging environment that has, let's say, one pod running per front end and back end, and then a production back end and front end that are running at, let's say, 5x, 10x, 100x that scale. So a little bit of my traffic is getting to my staging backends, and I can use that to monitor whatever my performance indicator is and decide whether that's the right change that I want to get. So basically, the users are getting, your staging environment is getting live user traffic in order to test it as close as possible to what will happen in production. So now that we've kind of seen how that rolls out, let's take a look at how you do that in Kubernetes. So I want to have two different sets of two different deployments, one for prod and one for staging, and I want to load balance against both of them with different amount of traffic going to each. So I would have a load balancer, or a service, or you could have a load balancer or a cluster IP, and I'm going to use the same selectors for both sets of deployments. So you can see here I have a prod front end and a staging front end. And I'm using the same labels so that this service is load balancing against both. Now, the one difference that I have here so that I can differentiate these when I put these in a monitoring system is I have one label for env prod and env staging. So now I can differentiate those pods as they come up and down in my environment. And you'll also notice in here that the replicas for the production environment was 90, and the replicas for the staging environment was 10. So 90% of my traffic is going to go to the production environment, and 10% is going to go to staging. So you can have a representative view of what's going on in your staging environment. So now let's look at what this workflow looks like once it's in practice. So I have a sample application, super basic here. So a front end and a back end service. The front end is load balanced out to the world, and the back end is internal. And let's go ahead and check out how this would look. So here I have my sample application on GitHub, and I have a branch. Sorry, let's take a look at what the app does. So this is the application here. It's just two cards that show you where this is running in Google Cloud. We can see here the version is 101, and I have orange cards today. So a product manager comes to me and says, hey, I really don't like the orange. It's super jarring. I would like to change it to blue. So as a developer, I would create my bike shed blue branch, push that, and here I've changed the color to blue in one of my commits. So from orange to blue, and I also bumped the version here from 101 to 102. Great. And we can see here that currently I have 101 running. This is a version endpoint that I have on my application that tells me what version is currently running per request. So I can see I have the old orange version running, and now I want to roll out the blue. But before I roll out the blue, I want to be able to see what that even looks like. So when I pushed that branch, Jenkins was able to build me that environment in the same cluster, and then I can use kube control proxy in order to test out that change. So here I can see that my cards are now blue. I've bumped my version, and I'm pretty happy with what I've got going on here. So I want to submit this to go to staging. So the way I'm going to do that is to submit a pull request from blue to staging. And that's going to tell me, okay, you're bumping the version and you've got the change to the color. And I'll go ahead and create that. And now I can go through whatever process we have set up in order to review this. We can bike shed about whether blue or orange is better. And eventually we'll decide that blue is the way we want to go. So I'm going to go ahead and confirm that. And now I can go over and see that Jenkins is going to index the branches periodically and see, oh, hey, you've got to change to staging. And you're going to have a build that's going to kick off in the staging branch or in the staging environment to roll out those changes automatically. So the developer didn't have to do anything. Another thing you'll notice over here is that I have one job per branch. So every time a developer pushes a branch, Jenkins will automatically create them an environment. And what that means in the Kubernetes context is I actually end up with a full namespace for that branch, and that developer has their entire environment encapsulated in that namespace. So when I'm done with that environment, I can delete the branch and delete the namespace, and that environment is then gone, and I can move on to other changes. So now we've seen that the build has completed, and we can look at the console output really quickly here. So I've built my container. Now I'm going to run the test within that container, and then I push that image to the repository. Once that's done, it tells me, I do the things I need to do in order to get my manifest ready for deployment, and then do a kube control apply. Once I do that, I also spit out the URL of my service so that it can be looked at. So now we should be able to see that version 101 is now rolling out with 102. So you can see here, the way I had mine set up is with 4 replicas. You can see here, I have 4 replicas of production, these 4 here, and 1 replica of staging. So about every 5th request should get 102, and you can see that traffic is trickling in now with that staging change. So let's say that we've gone through all the bike shedding. Everybody's happy that blue is the right way to go. Users are more engaged than ever now that we have blue. What do we do to get things merged into our production environment? We do the same thing, but with the master branch. So now we move staging to master, and we say blue is best, and create that pull request. Now we can go through another. Maybe there's a different process for getting from staging to master, and we've gotten through all those hurdles. We're excited to get blue out there to the rest of the world. We merge it, and now in Jenkins, it should detect that change soon and push all those changes back out to master. So while that happens, I'll show you guys what I was talking about with basically being able to label environments so that you can monitor them separately. So I had a label called env prod and env staging. So here I have 2 different sets of graphs that show me the CPU and memory. You could use any metric, custom metric, whatever you need to send metrics to Stackdriver, and Stackdriver can then display those for you in separate charts. So then I can see, okay, once I've made that change, is staging performing better or worse, or however you want to decide that staging needs to be pushed out to production. You can make that decision with data. So the way that this is set up in Stackdriver is I have a metric defined, which is a GKE container metric of used memory, and then I filter by the env label and say that I want only the pods that are in staging. So you can see here that I have a front end and a back end pod that are in staging there. So let's go check on our site here, and hopefully we've got master rolled out. Not quite yet. Let's see why. Don't feel me. Oh, there we go. Now it's kicking off. Sorry for the delay there. But that was kind of the whole demo here, and I'll take questions now if there are any, and we'll see this roll out.
Okay, so I'll, this is Matt. I've got some questions I can lead.
Yeah.
Looking at the slight delay, did you consider webhooks instead of polling? I'm just
I know that that's the right way to do it here. Just from a demo perspective, I got the simplest to set up. I do have the tutorials online. If you search for continuous delivery and Kubernetes, you should get to my repository here, the continuous deployment on Kubernetes. So this has the simplest things that you can do to get, from 1 to n steps and get this set up. Adding the webhooks would have a lot of customizability required in this tutorial. So I left that out for now, but that would definitely be the right way to do it.
Okay, right now, can you, while you've got this link open, can you drop this into chat?
Absolutely. And I'll drop a few more too. So let's see. All right. Oh, this thing's always getting in my way. Okay, so now we're at blue, and version 102 rolled out to all of our endpoints, and now we're only serving version 102. So that's the end of the demo there, and I will drop a few more links into the chat for folks.
That's great. Does anybody have any other questions? I have another one. Have you looked at Jenkins compared to other systems such as Drone or Concourse that are designed to be containerized, where Jenkins is Jenkins wasn't so much built around containers?
Yeah, I haven't had anybody have a concern with Jenkins being non-containerized. I don't know that that's been a huge issue. I think a lot of people look at the ecosystem and start there. And then once they hit some friction, maybe move on once they figured out their workflow. Because Jenkins allows you to, it's a blessing and a curse. It's very customizable and really is an empty box when you get it. So you have to fill it with all the right elements, and that takes some time to get your process right. Once you have that process right, I think that's the right time to look at other solutions that may fit that bag of tricks that you now have and that you now know you need.
Okay, yeah, I'm always one of those people who's happy to see CI in place, and I don't tend to have a problem with Jenkins or any of these. I just look for the differences, because I know a lot of folks who've and they've had this in any system, but they go, Jenkins, you're driving me crazy. What else?
Yeah.
You love it. It helps you solve things, but at the same time, yeah. Okay.
Yeah, I think the walk, crawl, run is a good way to do CI, especially, and CD definitely. So get incremental increases in productivity as you go, and then reassess every once in a while to figure out what that next leap is.
Yeah, I like that philosophy to it. Okay. Do we have any other questions? All right. Going once, going twice. All right. Vic, I think you were also the one who was going to talk about the Kubernetes charts update. So could lead us into that next section.
Sure. So we've been working hard over the last few months to get the charts repo in place such that. Can you guys see my screen? I'm just going to display the.
We do. Hey, we see what you were demoing before.
Okay.
I see charts.
Cool. So, we've been working hard to get a safe home for charts, and charts are the if there was a package for Kubernetes applications, the chart is the package for applications. And so we want to have a safe place for charts to live, where they're going to be curated, where they're going to be improved on, and there's a process for getting those deployed out to a repository where users can download them. So we've been working on what that process is and actually getting examples of what a good chart would look like, and then iterating on those patterns that we see from various communities coming in, and saying, this is a new thing that we think we can bake into other charts. So one example of that process that we've been working on is how to get charts to be able to reliably use persistent volumes. So we've ended up on a pattern that allows us to use persistent volumes using the dynamic volume provisioners, which means that now charts applications can actually be used with persistence, and they don't have to be toy applications, and you don't have to customize them necessarily to start using them for something more than just a demo. So now, for example, your MySQL and MariaDB charts have persistence by default, so you can start using them and know that your data is actually being persisted in case your pod dies and comes back up somewhere else, which is something that we really felt was important to get robust applications out there for people where they could trust the things that they get from the charts repo. And that's really what we want to promote with the charts repo, is that it's a exemplary version of that chart or of that application that users can really depend on. Now, we're not all experts in Kubernetes, or sorry, in all of these applications, but we do have examples of these Jenkins, MariaDB, MySQL, and WordPress out here that we'd like for the community to iterate on and help us make better. I've had a lot of experience with Jenkins, so I submitted that one, and Lachlan, for example, was able to help me make that one better. So we want to have these things in here that we can all iterate on and see the patterns that everybody else is using, and then improve those patterns. One thing that we came up with as kind of a requirement for the charts is that we needed a place where charts could incubate for a little while as they were getting hardened. And so we made the incubator folder here, which allows for charts that need are either using alpha features, which we are currently not putting in stable, or just need more, let's say, love from the community to figure out if they're the right way to deploy this application. So you can see here, there's charts like Console and etcd and Mongo, Patroni, which is a scalable Postgres implementation. These things use pet sets in most cases, but also are just require a little bit more tinkering to get right. And once they are as user-friendly as some of the other charts, they'll be able to be deployed in the stable repo. One other thing that we did for the charts repo is that all of the stable charts are now showing up by default in Helm, in the Helm default repo. So if you do a Helm, actually, I want to do it in here. So if you do a Helm search, you'll see all of the stable charts are making their way into the default repository. So if you get a chart that meets all the requirements for being in stable, you can get that deployed out to everybody in the community almost immediately. It takes about a few minutes for that job to kick off. And the requirements for getting a chart into stable are listed in the README here of the charts repo. So really, it's make sure that the user data is persisted, if that's something that the application does. Make sure that the application can be upgraded. So if you change the image version, for example, in a lot of cases, that's how you upgrade, that it doesn't do anything nefarious with your application data. That there is some level of customizability to the application, because we understand that not everybody's going to use these applications in the same exact way. So you have to give them some degrees of freedom there to change it to work for them. We also want to have a secure default configuration if possible. That means you don't have a MySQL database coming up and being open to the world on a load balancer IP with port 3306, things like that are kind of obvious to avoid. And the last one was that it does not leverage alpha features of Kubernetes. So you'll see a lot of charts in the incubator that are currently using pet sets. So once pet sets go to beta, those can all be migrated, or at least most of them can be migrated into the stable repository and pushed out via the Helm repo. So that was my update, and I saw Adnan on. I don't know if he had anything else to add.
Yeah, hey, thanks, Vic. Yeah, no, that was great. I think one of the things I would add is some of the things that we're still trying to figure out are best practices, and I think there's an issue in the charts repo about that. I'm actually sitting next to Samir, who's actually done some of the best practices for charts that we've kind of thought up. So yeah, it'd be great to get the ball rolling on that and start thinking about what those best practices are for manifests and charts.
Yep. Cool. Are there any questions?
Well, I'll start with the one in the chat here. Clayton asked, will you guys be supporting schema upgrades on those charts over time for things like MySQL?
Yeah. So typically, like, people define supported streams for content like this. So like, I'm going to support MySQL 5.6 until it goes end of life. Have you guys given any thought to how the chart would have to interact with moving across lifecycle versions?
Yeah. So, Eric and I talked about this a little bit a few weeks ago, and we're trying to figure out even not only just across versions, but across deployment types, right? So for Cassandra, you could have a static setup that's Cassandra comes up with 3 nodes and that's all you get. But you could also have a scalable Cassandra, and those should probably be different charts. So we've thought a little bit about it and kind of bifurcating the charts, but that's as much as I've thought about it personally. Did you have any ideas, Clayton?
I was going to recommend that, like, as part of the documentation, so you guys have like application upgrades. I think as you guys evolve the best practices, what'll be really good is saying what these charts won't do, because I think that we found that this is like the classic, like, I'm going to go support MySQL for you is an infinitely deep thing. And so, like, it's a classic long tail. All the easy stuff is getting it set up and running, and then all the really hard stuff that everybody gets wrong is the more complex. And having a good way in the charts repo and in the examples in MySQL to clearly delineate what this won't do and what the guarantees are and aren't really helps set the framing. Like, we talked about this for pet sets, right? Like, in previous calls, we've said we know pet sets have limitations. We want to be clear and upfront about those limitations so people aren't surprised. So like MySQL could say, the MySQL chart will prefer 5.6, and the application image used by that chart will deal with backwards compatibility for that image. And this is where you can go get questions answered about that MySQL image, about what it means for upgrades and compatibility. And here's the things that we are explicitly not dealing with. Like, if someone opened a request that says, I want to be able to add an environment variable or a parameter to the chart that changes the shared memory size of MySQL from 16 to 32, megs by default. Having a policy, like, this is just like really common stuff, because people will just keep asking for more and more things. Helping frame the charts repo in terms of what the expectations are and where the user's expectations start. So take the chart, fork it, add your parameters, consider contributing it back. Here's what we think of as the boundaries, are all good things to do in content repos like this.
Yeah, I like that idea of like the customization section maybe being, here's how you go do your own thing for a while. And if it's standardized enough where we see everybody doing it, we can bring that in as a core maybe value in the chart that then can be updated. I like that.
Right, and we've gotten to the point, like, the OpenShift MySQL template, I think, has like 20 documented parameters today, but I think customers have requested 30 or 40 more. And so what we try to do, for instance, is the config template for MySQL that gets applied inside the image looks for a set of environment variables. There's a set we support. There's a set that we say we won't support. And shaping that boundary where it becomes, hey, this is what we're offering you, and this is how you can maintain it on your own, and what that expectation is really helps.
Did you guys go down the route of giving people the ability to just supply like a my.conf config map? I think Adnan was going down that route a little bit.
We do, from a supportability perspective, that definitely changes the dynamic. For instance, if you want to, like, think about it like an API, right? If you let someone change myconf, you no longer control, like, all of the file system locations inside of your image now become a public API. And so, like, it's really helpful to think about your chart as what API you are providing and bound what API you don't provide. Like, inside our images, we say you can fork the image. Once you fork the image, you own the support lifecycle, and we'll answer questions. But we won't, like, from a Red Hat perspective, we don't support customers who fork images and add their own myconf. What we say is we will support you at the level that you would then drop down to, right? Support you as a MySQL user versus as an image user.
Yeah, I like that, the fork being the boundary there. Like, you're on your own once you've crossed this line.
And I would not be surprised if the vast majority of people who use charts are going to expect to be able to customize it, and separating, like, the savvy users, the people who understand MySQL and are comfortable taking that responsibility, from those who are going to say, hey, I used the chart, it didn't do this, why aren't you doing this? Say, well, you know, this is the boundary of what we support, and we'll gradually add things, but we try to be judicious about how we expand the API.
Yeah, and I think another element there is that it makes supporting the charts repo in and of itself much easier. You know, I've been getting pull requests to change certain charts, right? And it'll be easier if we can separate all the images out, and then each owner of those images can then have its own pull request, and it has its own life cycle. The only updates that would come into the charts repo are, we're bumping the image version because X, Y, and Z, and we could have a nice little release note for that image to say, here's what changed in this image that we've now bumped to.
Yeah, we try to name things, images, charts, templates, etc., along the lines of what we would expect to support as a stream. So, for instance, MySQL 5.6 would be a stream. Ruby 2.2 is a stream. Occasionally, you have people who want something like Ruby 2x, but the challenge is that in practice, as those evolve over time, the difference is, so you try to be it's kind of like there's really a gut kind of, what do you expect to be stable, and be a little bit conservative. I mean, so I'll say, you know, in practice on the OpenShift, we've supported most of these sorts of the simpler ones, the databases and the web frameworks. For the last 3 or 4 years, we support about 20 of them in fairly granular config type detail. That takes somewhere between 20 and 40 engineers working full time to support at a customer level. And then we get a lot of people who come in and say, I want this one tweak. And we know that the fan out cost past that point becomes very expensive as that API surface area grows. So we usually say, this is where you take ownership of that fork.
Makes sense.
I also think this is an area where semantic versioning could help identify the streams. You know, if someone just wants a security patch or something like that, they would pick up a update to a patch release, but they would expect a certain level of compatibility at the image file system level and in the config as well.
I don't like SIG-Apps anymore.
My only concern with the kind of mapping the application version
ever participated in
to the chart version is that the chart will change in different ways. Like, okay, maybe you know, config parameter has been exposed now. That needs to bump the version of the chart so that people can upgrade to it. But the image version never changed.
Yeah, and we have I posted an example in the link. So these are the OpenShift MongoDB streams. So these are like the base images, so Mongo 2.4, Mongo 2.6, and Mongo 3.2 that Red Hat supports officially. And then the image streams are basically just pointers to the Docker registry that contains them. And then on top of that, the templates and the parameterization, we support one level. But like semantic, I think, is a good suggestion because 3.0, I know 3.0 to 3.1 was a very unsuccessful semantic versioning for folks. So even if the vendor, like the database provider, thinks that they're going to do 3.0 to 3.1 correctly, it's generally good to be a little bit skeptical about that sort of claim and to be a little bit more conservative in those. And that's, again, like the forking aspect. What we found is that most people are successful with very small forks, forking the image to parameterize and minor versions. It does lead to sprawl, but I think the expectation is it allows people to solve their own problems.
Yeah, I think maintaining patches in your own fork should actually be pretty straightforward. I've actually been thinking whether it'd be more manageable to just have one repo per chart from the perspective of versioning, like create a GitHub org for charts and have one repo per chart, and then you can use Git tagging as well to help manage all the different versions.
We ended up definitely going to one repo per image and one repo per chart around it. Now, I think that makes it easy to fork on GitHub. And the boundary usually is, how do you get a CI infrastructure set up around that? So Vic, like the stuff that you're showing, like you really do need the set of tool chains that allows you to manage all of those and to test them in the integrated environment. So things like building and image testing concepts, like deploy this on Cube, test it, verify it works. And we run functional regression suites against each of our images. Those are typically co-located with the image and the template so that you get that kind of stack.
Yeah, and really, I like that approach. There would be a meta repo in my mind where that would be where I can, hook in to say, these are stable, these are incubator, these are the tests for X, Y, and Z, and have kind of those boundaries there.
Yeah, the link I posted is kind of, we started with a combined and then split it to get release maintenance. And then now we're saying we want to go back and do meta repos. So the link I posted is, an example of a meta repo that brings all these back together. Tying the image, so one thing that might be worth considering is the image. Over time, I would expect the images to be correlated with the charts quite strongly because they're combined API. There's an API surface area between them, and in practice, most people's images tend to evolve. And so there's some consideration as well about co-locating the images with the charts over time as well.
Yep.
One issue with potentially having separate repos for charts is that it now becomes more difficult for the community to contribute new charts, right? Because you need to set up a repo, and if that's a repo that needs to exist in the Kubernetes organization, that definitely adds a barrier, I think.
Yeah, and I think that the pulling it all together is a challenge. So if you look at what Heroku's done over the lifetime of Heroku with their build packs are in separate repos specifically to enable forking, because the Heroku pattern was clone this build pack and then run a bunch of scripts in that fork. But in practice, what they ended up doing was made it very easy for people to fork the build pack and use it on their own. And so there's a trade-off in tension there. But Heroku did go back later and started pulling together the meta. Here's all build packs you can use. The total number of build packs right now, I think, is somewhere in 150 to 200. And not all of them are listed. And then there's a large number of forks. Really, the only discoverable ones are the ones in that list. So that's an important consideration as well.
So how well does it work if we just make it easy for people to fork the entire repo and then somehow comment out everything they don't care about? And then build, and then it'll just build the one or two things they care about. They can still rebase on upstream and just ignore stuff that it's not relevant to their subdir.
I don't think that's the end of the world to start with, for sure. I mean, again, this is think about this in terms of what is the primary goal here. The primary goal of the charts is to encourage people to find working examples on Cube as a good 6-month goal, keeping everything together, and the process allows it to evolve. Totally reasonable. I just wanted to point out, as we've moved from examples to things that we support as a company, where people pay us large amounts of money, well, not large amounts of money, but we try to get them to pay us large amounts of money to support this stuff. Having those kinds of considerations be built in. I don't know that charts will always end up there, but some of the considerations are the same.
Yeah, totally. And I think we're right now in the walk phase. At least that's how I've discovered a lot every time I get a pull request and see what people are doing. We still don't have best practices for what we think a chart is. For the walk phase, I think it's totally viable to just keep everything together. CI gets a lot easier. We learn a lot from that process as well. And then as we see it being a challenge and people are coming in with all kinds of pull requests to change each chart, that's when we can make the decision to split things out. I don't think it would be terrifying to do so, especially if we could keep the repo today as the meta repo. I could see a path there that wouldn't be devastating.
Yeah, so definitely in the expectations around a chart and best practices, clearly defining what the expectations are and defining what the APIs are is something I would recommend from the very beginning, just to set expectation.
Thanks, Clayton.
Sounds good. This was a lot longer discussion on a simple question than I anticipated. So thank you. Does anybody else have any other questions? Good. So the next thing that we had on the agenda was to actually discuss, we have prioritized the different things we will be going after to a certain extent. But one of the questions has come up, how do we want to pull these different projects into the SIG-App stand-up to have discussions on them? Because we've got more than one. And Michelle was looking to, she had the question, how do we want to pull these in so that way we can discuss them, give them time? Do we treat it like a stand-up? Do we want to give presentation? What kinds of characteristics do we want to pull into this meeting on a regular basis in order to keep everybody appraised of what's going on and, try to spot if there's a problem early, that kind of thing. And so I was looking for discussion on that.
So I would say the teams that have their already effective subteams should continue to act as effective subteams. We should identify them and have them give mini stand-ups or many quick, reports. And people can always go to those stand-ups. So for Helm, App Controller, and the work like that Vic and Adnan and those guys are doing, those all seem like independent sub-issues. On the rest, we probably could break it down into there's a lot of areas. I think there's more areas than some of the other teams do. So maybe we could break some of those into groupings, like the deployment and replica set stuff and jobs are roughly correlated. Pet sets is roughly correlated, and then maybe do quick stuff on the rest. Just looking through this list, even the things that we said we might do for 1.5 is not that bad, I guess.
Do we have more material than we can cover in one SIG between controllers and everything on the list?
I was going to say, I think the good thing about the Helm and the app controller stuff being effectively sub-SIGs is it does take some of the pressure off that to be discussed in this meeting. I mean, I don't know if beyond that we do, but.
Yeah, and so we've been having the Helm folks, usually Matt, just give us a quick update. Should we also do that for the app controller work? Just
Probably.
a quick update for those of us. Is there somebody here who wants to take on doing that? Who would be the right person?
So is app controller being built as a target to integrate or as a closely coupled thing?
As a thing on top is the current, like as an extension component, a little bit like Helm.
Then that model sounds good.
Who's leading that workup? If I was gonna go track down one or two people.
I can't say his name. I would murder it if I tried. But it's
Okay.
Pigman on
Is he or she?
he's the first name listed in the app controller list.
Okay, I will go track him down, and I will also attempt not to butcher his name by saying it here. I will politely ask him. So I'll take the action to go track him down.
And then I think Matcha and Eric handle the job stuff, and then McCallus and McCall and anyone else can handle deployments and replica sets. And then Prashant and I can handle app or pet set status. And then I guess there's like a smaller set of sub items. Do we want to track those each item? I don't know that there's as much work in this SIG for those.
I don't know. I'm curious how much of this we're actually going to attack, because there's a lot here and a lot of folks distributed across these. So we have.
My gut would be that we would allow folks to make as much progress as they can, because, for instance, I think we're already at the point in Cube where the releases are too short for anybody to go from idea to completion. And so we need to be working in a model where we have our relative priorities, we have the people assigned to them. We try to make sure that the higher priorities get called out and people work to bring those to completion. But we would expect that some of the lower priority items, it doesn't matter that they're not going to ship in 1.5, because if we don't start working on them in 1.5 in parallel, they'll never make it into 1.6, 1.7, 1.8. But they shouldn't take away attention from the priority ones when it comes to reviews and discussions.
I can't tell if you're saying that there should be independent work on many of the controllers with decentralized review, or if you're saying we're just not going to get that much done, but people can prototype stuff.
I think I'm saying both of those, which is, I think we're already at a point where there's more people working on the topics that this SIG covers than could be realistically delivered in one release anyway. And we want to make sure that there's an effective pipeline from prioritization to review time to developers able to accomplish things independently. I mean, I think it's a combination of both of those. I wouldn't expect to get any of the priority 2s in 1.5, but I would expect for not just throwing engineers at priority 1s and expecting them to get solved.
Every engineering project needs a single owner for its constrained resource, whether that's power or whatever. I claim that our constrained resource is API complexity, so let's not lose centralized control over the API complexity budget.
Agreed. And so API complexity budget, Eric, are you viewing that as restricting the amount of features that we would consider adding into Cube over a unit time? Or are you viewing that as amount of features we would focus on review work for a particular release?
I think those have the same effect, but I think I mean the first one is closer.
Okay, I agree. Is there anybody who disagrees with that on this call? So maybe for 1.5, what we should try to do is focus on the priority 1s and ensure that the review bandwidth for API changes matches the amount of review bandwidth we're able to spend among the people who perform the various reviews. And if, I guess the question is going to come down to, within the priority 1s, are there already too many for what we think of as the review bandwidth load?
So personally, I plan to be highly focused on pet set for 1.5, and I don't have any other things that I'm sure I'm going to give time to. I might give other stuff time. So the question would be, who else would be in the set of people that would be able to review API changes? Maybe you, Clayton, maybe Brian. We should discuss, or do we think there's other people we want to expand that to?
I think we should get the list of API change reviewers for the SIG, and then try to work that into how do we broaden that to match the expectations, which is, we have a fair number of people involved in the SIG who've worked in the APIs for a long time, but we don't have a large number of people who've done API reviews for a long time. We have a smaller set of API reviewers than I think some of the other SIGs have. Like scheduling is an example of one, which there's quite a few people who are doing reviews. So maybe that's a to-do list, is to draw up the reviewer list and figure out how we connect reviewer time with API time in the prioritized order.
Yeah, that sounds good. I'm actually recording a to-do for us in the background to collect that list, and to we probably need to make some group on it so you can reference it in issues.
Yeah, generally that would be like in the other SIGs, we certainly try to make sure that there are the concepts of both owners and an API review are slightly disjoint from the SIG notification, but the SIG notification usually the SIG list usually is the first pass. I don't know. This is maybe a more discussion point for a larger audience, which would be sharing finite review attention for API changes. Needs to be a little bit more formally discussed across all the SIGs.
I actually thought that API review was a single function across all SIGs, and you're describing it as a per SIG function. So I think we definitely have reasonable but different expectations about what that means, and maybe that's a top-level Kubernetes discussion to have.
Yeah, I meant it more in terms of within the SIGs, how much bandwidth is there to weed out all of the obvious and wrong stuff, as well as somebody on the SIG who develops into people on the SIG who are able to start working from the perspective of reducing all of the problems that might arise during API design and review. And then the flip side of that is how do we get involved early to go in and say, this doesn't match any of the rest of our API designs. Before we even go further on this feature, we need to get bandwidth to specifically bless. So I think like daemon sets updates is an example of that, where it's a relatively new pattern that we have no behavior that is exactly like that. And it really does need somebody, a set of people, Brian and others who've been involved in this to weigh in. And Eric and yourself and myself and various others, like, how do we make that happen for the items that are going to be the most, should we go through these and identify the ones that are going to be most difficult from an API perspective and then prioritize relative to the time we have and the priority on them? Like as an example, if we don't think even now we're going to get daemon set update attention on it for a 1.5 timeframe, there's no point about prioritizing it or working heavily on it because we're not going to be able to get that attention on it.
I would suggest that for 1.5. Because
I mean, I saw Brian's concerns about that one as well, so I kind of agree. I do think it's somewhat tied up with pet set updates, though, and we have said a pet set update design strategy is targeted for, was a beta criteria. Okay, I don't know that we have an answer for that then. So I think that's a takeaway. At least Eric, you, Brian, and I should chat on one of the mailing lists around this.
All right. All right. Yeah. So when you have a solution to that, please come back to us and let us know. We've only got 4 minutes left, and so normally we have a Helm update. And so Matt Butcher, are you on the phone?
Yep, I'm here.
Can you give us a quick update on Helm before we all run for the hills?
Yeah, sure. Yeah, super quickly. Huge thanks to Adnan and Vic and their respective teams. They have been really pushing the envelope, and we're seeing some really awesome stuff coming out of the charts team. And the Helm team itself is just super excited about what we're seeing. So big week for us because our goal is to have Alpha 5, which is our final alpha release, done by the end of this week. We appear to be on schedule. We've got a couple big PRs still on the way. After Alpha 5, we make that transition into the beta phase, which means all we're really going to focus on is fixing bugs, improving documentation, making installation and testing and CI/CD better. So we're really optimistic that if we can make this successful transition into Alpha 5, we're going to be on the stability train. Practically speaking, what that means is that new features will go onto the 2.1 roadmap item. And so we have already started moving over some of those in the issue queue. So if you create a new feature request today, there's a pretty good chance you won't end up on the 2.0 milestone. But we're really excited about this. This marks a big transition for the team. So by Friday of this week, you can expect to see the Alpha 5 release come out. That's all I got.
All right. Thanks for the update. And with that, we've got a couple minutes left. Did anybody have any last minute things? Going once, going twice, going 3 times. Thanks, everyone, and we will see you online or back here next week. Have a great week.
Bye.